Today, we will introduce the UHV-2000A Partial Discharge Detector for you. This is our partial discharge detector. This instrument has the PD-free testing capabilities. To complete this test, a set of PD-free step-up devices is also required. This is the partial discharge-free step-up device. There is a control box for the test transformer, an isolation filter transformer, a test transformer, a resistor, and a capacitor. The UHV-2000A is different from some handheld partial discharge detectors on the market. This is because the measurement method used by the UHV-2000A is currently the most internationally recognized measurement method. It can directly measure the partial discharge level of our products or electrical equipment, which is a capability that handheld partial discharge detectors do not possess. However, its requirements are also very stringent. As we mentioned, it requires a partial discharge-free power source, and it also has certain requirements for the environment and background noise. Under special environmental conditions, additional measures such as shielding may be needed to use this equipment. First, let's talk about wiring. Connect the control box of the test transformer to a 380 kV power supply. Here, the meter output and ground wire must all be connected. Connect them to the isolation transformer. The output of the control box is connected to the input of the isolation transformer. The output is connected to the test transformer. This point must be grounded. Connect the output of the isolation transformer to the input of the test transformer. The meter of the control box is connected to the meter. This point is grounded. The top of the test transformer is connected to a protective resistor. The other end of the protective resistor is connected to a coupling capacitor. The low voltage output of the coupling capacitor is connected to the initial input of this unit. Then, the ground is connected to ground. The initial terminal is also grounded. This wire is the calibration unit of the pulse generator. The black wire is grounded. The red wire is directly connected to high voltage. The partial discharge signal wire goes directly back to the main unit. The signal wire is connected to channel 1, but it can also be connected to channel 2. This is a dual-channel system. The instrument's ground is connected to the ground. Plug in the power supply, and calibration can begin. Before boosting the voltage, the calibration pulse capacitor generator must be removed. Click Run here. A value will be displayed. Now, click Stop. The displayed value is approximately 12.6 pC. This is the current discharge level, which is caused by the background environment. The measured value obtained afterward must subtract this current value to determine the actual partial discharge level being tested. Click Run to start. Begin boosting the voltage. Now, power on. Then, reset the voltage regulator to 0. Click Start. Begin increasing the voltage. The upper display is the voltmeter, and the lower display is the ammeter. Here, we only need to increase it to 50 kV. You can clearly see that the capacitance has increased. Generally, before conducting a test, the background capacitance should ideally be below 5 pC. If it exceeds 5 pC, measures must be taken to reduce the environmental discharge level. What we are doing now is just a demonstration test of the instrument. Background noise can be eliminated using the instrument's software. Before using the instrument, pulse calibration must first be performed. After pulse calibration is completed, i.e. before boosting the voltage, the pulse generator must be removed.